Hello, my name is Rico Tyler and I am a master teacher with the SkyTeach program at Western Kentucky University, and I work in the areas of physics and astronomy. What I'd like to do today is to talk to you a little bit about how a rocket engine actually works. To understand how a rocket engine works, you need to know about Newton's third law of motion. For every action, there is an equal and opposite reaction. Now we talk about actions and reactions, but that is meant to refer to a force. For every action force, for every time you push, there will always be a second force, an equal and opposite force that pushes in the other direction. A very common example of that would be a pistol or rifle, or in my case, a small cannon. If I took this cannon, loaded a small amount of gunpowder in the barrel, put a bullet into the barrel, and then set off the gunpowder would explode. The pressure of that exploding gas would apply a force to the bullet and push the bullet literally out the barrel. But that's only half the story. The same force that pushes the bullet out the barrel has a reaction that pushes the barrel in the other direction. The forces are actually equal. So as the bullet is pushed forwards, the entire cannon, it recoils backwards. A rocket simply does the exact same thing on a much bigger scale. If we talk about a spacecraft, like this model right here, if it were the real thing, instead of gunpowder, the rocket uses some sort of fuel. It could be kerosene, it could be hydrogen in many cases. Instead of a barrel, there's a rocket nozzle which the fuel mixes and burns. The difference though is there's no bullet. Instead of a bullet being thrown out the engine, the burnt fuel itself, the hot incandescent gases from the burning, become literally atomic-sized bullets. As they burn in this engine, they're literally pushed this way. And for every molecule of gas that's pushed out this way, the same force pushes the rocket in the other direction. And that reaction force actually pushes the rocket into space. And given enough fuel and a hot enough burn, a rocket like this, the real thing, could move from 0 to about 18,000 miles per hour in about 10 minutes.
That is perfect.